Good morning. Today we are going to return to factoring. I mentioned earlier this year that factoring is one of those math skills that doesn't really go away. It's just something that keeps coming up from one class to the next and is something that we keep going into further depth with. And so while you don't necessarily need to be an expert at factoring, you do need to be what we might call proficient and confident in the basic steps for how we factor. So I am aware that factoring is often the nemesis of a lot of Algebra 2 students. And so I want to take a moment and just review the steps for factoring that we've already covered this year. So basically, if you did the tutoring session that I did on factoring, I really tried to emphasize like a kind of a flow chart for factoring. And I've really emphasized this, that when you're factoring, the first thing that you need to do is to factor out a greatest common factor if there is one. And so our first step is factor out a GCF, a greatest common factor, if there is one. So if there is one. There isn't always a greatest common factor or any kind of common factor. If there is, you want the biggest one. But you want to check for one, and that has to be like the first thing you always do when you're looking at a factoring problem. Don't make common factors exist if they don't exist, but you always have to check for them first. Then once you've factored out the greatest common factor or determined that there isn't one, then we look for what's called a special case, and you're going to factor the special case. So check for a special case, and you'll notice that the title of today's lesson is Return to Factoring Special Cases Part 1. And up until this point, we've only had one special case. And so that was I can't make a dot there. There we go. The difference of squares. And just to kind of refresh your memory on that, that's the a squared minus b squared. So if you difference, of course, means subtraction, and then what you're subtracting are two perfect squares, and those always factor into conjugates. What we're going to start in this lesson is a couple other special cases that you should look for. And that's going to be the sum and difference of cubes. Sum and difference of cubes. And notice this is going to be similar to the one we did before. Before we were just talking about the difference. So again, we have difference, that means subtraction of cubes, but also the sum, which is adding. So this is going to be one where we can both add and subtract, where when it squares, it's only just subtracting. The other one is a strategy that's called factoring by grouping. And a lot of you were factoring this way to do your trinomials. You are changing them into a group of 4 and then factoring in groups. So if you are one of the people that's been doing your factoring that way anyway, that's going to actually be really, really easy for you. And then after you've factored out any special cases or determined that there isn't a special case, then you factor the trinomial. So probably at that point, factor the trinomial, and you would use slide and divide if needed. Use slide and divide if needed. And you don't always need slide and divide. That's for when you have a leading coefficient, but that's the step when you would use it. Now, this is not foolproof. This is not going to get you through every single factoring problem in the universe all the time. There are going to be cases that we haven't looked at, or like twists on cases where you might have the difference of squares, but it's actually like you're squaring a square. Like there's some weird things that can happen. But that's not common. So this method will be pretty good most of the time when you are asked to factor things. So before we enter into these new things, the sum and difference of cubes and the factoring by grouping, I wanted to just do some quick examples, like reviewing what we already know of factoring. So I have a couple examples here. If you have 6x squared plus 5x minus 4. So we would look for a common factor. I have an even number. 5 is a prime number. And so if you look at the 5 and 5 is not a factor of 6 or 4, then you know that there's no common factor. And of course, there's no x down here with the 4 is, so you can't factor out any x there. So once you determine that there is no common factor, then you check to see if it's a special case. Now we've only covered the difference of squares. So at this point, you just check to see if it's the difference of squares. Well, I see a plus sign and that's not difference. So we'll toss that one out. And that means we bump down to this, which is factor the trinomial, use slide and divide if needed. Slide and divide is used when you have a leading coefficient other than 1. So we take the 6, we slide it down using multiplication. 6 times 4 is 24. Then we factor as usual. So we look for two numbers that multiply to negative 24 but add up to 5. Some of you come up with those numbers really, really fast because you know your times tables really well. Others of you take a little bit longer. One thing that you can do if it doesn't come to you is you start listing the factors of 24. And we have a bunch of them. And this is the pair that can give you a 5. It would be a 5 if the 3 was negative and the 8 were positive. So negative 3 times 8 would give you the negative 24, and negative 3 plus 8 would give you the positive 5. So we'll do minus 3 plus 8. The name of the strategy is slide and divide. If you don't divide, you won't be satisfied because your answer will be wrong. So we make sure we divide. Next is the step that's super easy to forget because we don't always do it, that it's simplify the fractions. So we have to look at the 3/6 and simplify that to 1/2. And then 8/6, if I do a little bit of scratch work over here, 8/6, I can divide both of them by 2, and that becomes 4/3. And then the last step is you slide the denominators back. So we get 2x minus 1 and 3x plus 4. And that takes us through the slide and divide. Again, we've covered this. Like I spent a whole lesson teaching it. I'm not doing that right now. But I know that if you haven't factored in a while, you do kind of forget how to do it. And we need that refresher. Another quick example is 3x squared minus 243. So that's kind of big. But our first step always is to look for that greatest common factor. So we're going to check that first, especially when the numbers are big. And it turns out that there is a common factor, and that common factor is 3. Quick way to tell if 3 is a factor is add up the digits. So 2 plus 4 plus 3 is 9. And since 9 is divisible by 3, that means that 3 must be a factor of 243. So I'm going to take the 3 and factor it out. If I have 3x squared and I take out the 3, I will be left with x squared. Minus, and then 243, we're going to factor out the 3, and I'm left with 81. Now we move to the second step. Check for the difference of squares. That's when you have a perfect square minus another perfect square. And in this example, you'll notice that we have a perfect square. X times x will give me x squared, minus another perfect square, which is 81, which is 9 times 9. And that's going to factor into our special, we have the special word, conjugates. Make sure you know your vocab. And we take the square root, x times x gives you x squared, and 9 times 9 gives you 81. And one of them is a plus and one of them is a minus. Don't forget the 3. The 3 was there, the 3 is still there. And so there's our factoring. So what we managed to do there in 2 quick problems in less than 10 minutes is that we reviewed getting out of GCF, we reviewed the difference of squares, and we reviewed slide and divide. So everything that we've already known about factoring, we've dug it up from the back of your brain wherever it was. So next special case is something called the sum and difference of cubes. And what I'm going to do to start this off is I'm just going to give you the formulas. Okay, I'm going to give you 2 kind of yucky looking formulas, and then I'm going to let you look for some patterns. We want to see some patterns, and I'm going to give you a mnemonic device for remembering it. Generally speaking, most students, after they do a couple of these problems, don't find them that difficult. So the first one is going to be the sum of 2 cubes. And by cubing, we mean raising something to the 3rd power. So A times A times A, or B times B times B. If you saw that and you were being asked to factor it, this is how it would factor. You'd have a little parenthesis and you'd have a big parenthesis. Inside the little parenthesis, we would have A plus B. And inside the big one, we'd have A squared minus AB plus B squared. The other formula is for the difference of two cubes. So that would be A cubed minus B cubed. And when you factor this, you also have a little parenthesis and a big parenthesis. In the little parenthesis, we have A minus B. And in the big parenthesis, we have A squared plus AB plus B squared. So what I'm going to do, if this is a live class, we're just going to ask you what you see as a pattern. And in the virtual class, I'm going to pause the video and I'm going to let you look at it for a little bit and see what are the similarities and what are the differences between these two formulas. Okay, now obviously when I'm recording this, I don't know what people came up with and I have to kind of keep talking anyway. But usually what students notice is they notice that the letter parts are actually the same for both of them. So you go A, B, A squared, AB, B squared. A squared, AB, B squared. And so the actual letter parts are the same for both, which is really great because now you only have to memorize like one set of letters instead of two. Other things that students will often notice is that like the signs, the pluses and the minus, like B squared is always positive, or they might notice that the very first parenthesis matches the original problem. So like a plus sign goes with A plus B, a minus sign goes with A minus B, and so forth. So there are certain things that you can notice if you take the time to look. Now, there's a couple things we need to talk about, and then I'm going to give you a mnemonic device. One thing, in order to be able to recognize like the difference of squares, you have to recognize your perfect squares. So in perfect square land, you have to recognize like that, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. And most of you know those numbers. I guess that should be squares. There we go. You know those numbers because you memorize your times tables at some point. So somebody made you memorize 7 times 7, and so you know that 49 is a perfect square. With this, you actually need to know your perfect cubes. And most of us don't know our perfect cubes because nobody ever made us memorize them. That would be 1 cubed, 2 cubed, 3 cubed. How far did I go out in my notes? 4 cubed, 5 cubed. And just like with perfect squares, there's an infinite number of them. And you can kind of figure these out. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And you'll notice 64 is also a perfect square. So 8 times 8 gives you 64, but also 4 times 4 times 4. And then 5 times 5 times 5 is 125. Once you get past that, the numbers actually get really, really big. And if you think of most factoring problems, you don't really have really, really big numbers when you're factoring. So chances are, if you are going to have to do the sum or difference of cubes, you're going to be seeing one of these numbers. The chances of you seeing a number bigger, like could it happen? Sure. Like 6 cubed is not going to be super, super big. But if you can learn these ones, and then you can check for other ones. You can check and see if it's a perfect square, or perfect cube. Now, here's the mnemonic device. We're going to call this a soap sandwich, and on the video, you're not going to get to see my hands do the soap sandwich thing, which is kind of a bummer. So here's the mnemonic device. It's called a soap sandwich. I stole that partly from a textbook and partly from Miss Braswell. So the word soap, here's what it stands for. It stands for same, opposite, always, positive. And that describes the signs in the formula. Same, opposite, always, positive. And then the sandwich is how we do, well, let's go back here. Let's talk about the same, opposite, always positive. So we'll do that first, and then I'll talk about what the sandwich is. What it means by same, opposite, always positive is that the first sign in the problem is always the same as your original. So if you have the sum, you're going to start with a plus sign. If you have a minus, you're going to start with a minus sign. Then the next sign is always opposite. So it's always flipped. So you start with positive, then you're going to flip to a negative. If you start with a negative, you're going to do the opposite, which is positive. And then, of course, always positive is a way of saying that the b squared is always positive. So same, opposite, always positive. I will give you partial credit if you can get that much. Same, opposite, always positive. Now, the SOAP, that's the SOAP part. And then the sandwich part is this. You look at the a squared and the b squared. So once you identify what a and b are, you square it, smush it together. Like a SOAP sandwich. So the first one, that's a slice of bread, and then you smush it together. And in class, I do this with my hands. I'm going to put my iPad down. And you do square it, smush it together. And I clap my hands. Square it, smush it together. And so you make yourself this SOAP sandwich. And that's the acronym. So in the future, we're going to talk about these. These are the SOAP problems, or the SOAP sandwich problems. And what we're referring to are the sum and difference of cubes. So nothing helps like an example. So we'll do, I don't know how many examples I have. I have 3 examples and some practice and a horrifying check by multiplying, but we'll see how much I feel like doing. So first example is x to the third minus 27. And so first you want to recognize, of course, x to the third is a perfect cube. And so it's like x times x times x. And 27 is on that list. And you'll get comfortable with that list. So 27 is 3 times 3 times 3. So what we've got here is x to the third minus 3 to the third. So here's the formula. A cubed minus b cubed. And here's our factors. So little parenthesis, big parenthesis. SOAP. Same. So we're going to have a minus sign right here. Opposite. So we're going to flip this. So we're going to have a plus sign. And then always positive. And I like to put those signs in first. You get partial credit for doing that. Same, opposite, always positive. Then you want to figure out what was cubed. So here x cubed gives you x, and here the 27 is 3 cubed, so you have a 3. Then you do this. Take the first one, square it, and you get a slice of bread. Take the second one, square it, and get a slice of bread. So that would be 3 squared, which is 9. And then you take these two here, and you smush them together. We wouldn't normally write x times 3, though. We would write 3x. And we're done. Ta-da! Square it, smush it together. Okay? And I actually have in the notes, I have square it. So I actually wrote it out. Square it, and then sandwich it right here. Right there. And then I'll square it, smush it together, and you're not even seeing how my hands move. All right, let's look at a different example. So we have 8, you can just pretend that you can see my hands moving. So we have 8x to the third plus 1. And again, with some practice, you will begin to recognize that 8 and 1 are both on that list of perfect cubes. It's not a super long list. Kind of keep it handy and keep your calculator handy in case you get like a bigger number. And so we recognize this as the sum of 2 cubes. We have a little parenthesis, we have a big parenthesis. We have to ask ourselves, what cubed gives me 8? 2 cubed gives me 8. So that's going to go in the parentheses right here. And then, of course, x to the third power gives you the x cubed. And then what raised to the third power gives you 1? Well, that would be 1. Now, I forgot to do my signs. Silly me. Same, opposite, always positive. So we have a plus sign. It's going to be another plus sign. Then you take the opposite. So same, opposite, always positive. Now to get the slices of bread, we need to square it, smush it together. So I'm going to take 2x and I'm going to square it. Now just be careful when you do this. I'll do a little scratch work. 2x squared means 2x times 2x. So you're going to square the 2 and get 4. And then square the x, which is going to give you x squared. Square this, square the 1. 1 squared is just 1. And then you're going to smush it together. 2x times 1 is 2x. And we're done. Ta-da! Beautiful. One more example, because examples are fun, so why would we not want to do this? We have 64x to the third plus 512. That's terrible. Okay, now I have in my notes that we suspect that 512 is a perfect cube. So you're kind of faced with this big number, and you go back to your notes, which of course you're taking, and you realize like 512 is off the list, but it might be a perfect cube. So you grab your calculator, you go look at your calculator, and you kind of tick around with it. Do like 6 to the third power, 7 to the third power, 8 to the third power, and eventually you will come up with 8 to the third power. And so 64 is 4 to the third power, and 512 is 8 to the third power. So we are confirmed, and yes, this is the sum of two cubes. Little parenthesis, big parenthesis. Same, opposite, always positive. Get those signs in there. What raised to the third power gives you 64? Well, we just did that. That's 4. What raised to the third power gives you x cubed? That would be x. What raised to the third power gives you 512? 8. Now we're going to square it, smush it together. When you square it, make sure that you square the whole thing. So it's going to be 4 times 4, which is 16, and then x times x, which is x squared. 8 times 8 is 64. And then you're going to smush these together. So 4x times 8 is 32x. And there you go. It's not super difficult, but it does take practice, and you will totally forget it if you don't practice it. So you really want to make sure that you're doing enough problems to get this stuck in your head, because you'll probably forget it before the test, and you'll have to do that refresher, and it'll be so much easier to refresh your memory if you take the time to practice it. Now, last thing I want to show you is how you check your answers. So let's say you're doing this problem. You're like, oh, these problems, these numbers are huge. I don't know why I picked this one, but these numbers are huge. I wonder if I did it right. Well, remember what factoring is. Factoring is the undoing of multiplication. So if you want to check to see whether or not you have factored it correctly, you can go ahead and multiply it. 4x times 16x squared. Well, 4 times 16 is 64, and x times x squared is x to the third. 4x times negative 32x, that's lovely. 4 times negative 32 is negative 128, and x times x is x squared. 4x times 64, well, 4 times 64 is 256, and then of course you have the x. On the inside, 8 times 16x squared is a positive 128x squared. 8 times negative 32 is negative 256x. And 8 times 64 is 512. And then what you'll notice is that a bunch of these things cancel out. So you've got negative 128x with positive 128x squared, and then 256x and minus 256x. And notice what we're left with. We're left with 64x to the third plus 512. And that was the original problem that we started with, and that's how we know that we factored it correctly. I don't expect you to do that process of the checking, but I did want to make sure that I at least showed you how to do it. It's just a lot of distribution. It's nothing new. It's just like got an extra step in it. So you're just distributing the 4x, and then you're distributing the 8, and then you're combining the like terms. So I'm going to put some quick practice problems up on the screen here, and then we'll call it a day for special cases. So there they are. We have x to the third plus 8, x to the third minus 125, and 8x to the third minus 64. And that concludes our lesson.